Hi, this is David again, or Dave. Welcome to my YouTube channel, and this will be another video presentation where I'll be using the services of my homemade Variac, and I'll be testing not AC fans but still AC based appliances or mechanical electrical devices. So in this case, in front of you you have two of these very miniaturized but very handy induction motors, and the equipment remains the same as it was in the introduction video on the Variac. So I have my VoltCraft VC404 multimeter here and my screwdriver, and the rest is already attached or comes with the Variac itself. So the testing cable and of course the power cable that will be connected into that power cord. As usual, I'm going to give you a visual inspection on both of these induction motors, even though by design and model number and additional specifications they are both the same, but nevertheless. Now this is the first one. This is the information that is printed on this silverish sticker. As usual, I wasn't able to find anything in terms of confirmation or additional specifications on the internet because these two induction motors are a very old piece of equipment that I have lying around in my workshop, 30 years definitely, or 20 years for sure. So the internet wasn't really helpful, so I'll just have to go along with the information that is on this label. Nevertheless, so we're looking at the motor from various angles. Yeah, it's made in Japan. Naturally, everything good is from Japan. This is again, I think, the manufacturer, Oriental Motor. Let's look at the bottom side. Again, Oriental Motor and made in Japan. So in terms of cosmetics, how this is preserved, it's almost like in a mint condition, if I were to say so. So there isn't any rust or corrosion, perhaps a little bit here on the shaft. But other than that, in terms of screws and overall chassis or in the metallic, I think this is actually aluminum enclosure, except of course this part, this is iron or steel. It's very well preserved. A little bit of history. These motors supposedly came from a very old computer server, but I actually doubt that, even though I'm not really a specialist or an engineer. Let's say that I believe that. And this motor feels kind of heavy. It weighs a little over than 1 kilogram, to be precise, 1172 grams. So we look at, if we're talking about dimensions, the length, if I include this shaft, would be a little below 10 centimeters, to be precise 94 millimeters. And because it has a square design, these two sides would be the same, and one side is 7 centimeters and this one would be also 7 centimeters. And then this piece of shaft or axis that is looking outside or sticking from the enclosure chassis, it sticks out about 2.5 centimeters, and the diameter of this axis is about roughly 6 millimeters. It comes with this sort of a connector. This is where you would probably install some sort of a pulley system or something like that, but you can also remove this by unscrewing this screw right here, which locks this coupling into place. I think you would need something like a inbus key or similar. And last but not least, you have if you want to mount this motor somewhere you have 4 mounting holes. I think the screw that would fit inside this would be in a M5 screw, so Phillips, or the one with the flat surface. Let's see what else. Well, that would be pretty much about it. Well, let's just look at the wires or the wiring. Every induction motor or asynchronous motor comes with a startup non-polarized capacitor, and this one is no different. It comes with a Marcon 150 volt AC 2 microfarad capacitor. This would be the grounding wire that would be attached somewhere on this aluminum case. I don't know why isn't this already connected, maybe somewhere like so. But for the point or purpose of this presentation, I'll be probably just sticking this underneath here in order to make that grounding connection. And it comes with this unknown type of female connector. Of course, you can chip this away and solder in new wires or install a different connector to your choosing. But this male connector that is here is actually perfect when I'll be connecting or inserting these 3 wires into that coupling over there on the testing cable of the Variac. So this will be very handy and safe when I'll be testing this. It spins nicely and freely, so we'll be testing this in a moment. Now the second motor, which is the same one as the first one or the previous one, has a little bit of more signs of wear and tear in terms of corrosion or rust on 2 screws, this one here, and a little bit more on the head here. And the second one, where is the second one? Yeah, this one, this screw right here. The corrosion is only here, it isn't on the side of the screw. So this can be, just sort of, you can unscrew this screw from the body and polish it a little bit, and then add some little bit of oil if you wish. But still, it doesn't diminish its function anyway. So the body, the chassis, the metal enclosure is also pretty much almost in mint condition as the previous one. No deep scratches or dents or something that is chipped away. Yeah, it's pretty much also, this one is even better preserved if I look at the shaft. Shaft pretty much doesn't have any rust or corrosion, unlike the previous one who has a little bit. Yeah, so only these 2 screws on their head have a little bit of rust. But nevertheless, it also spins well, and I'll be testing this one in a couple of moments as well. It also has the same capacitor from Marcon and the connector. This is how this female connector looks like up close. The same grounding wire. So that's pretty much it on this part of the presentation. Now what else do I have to say? Well, pretty much nothing. Now I'm just going to hook up everything, the multimeter, the testing cable, and this motor into place, and we'll continue from then on. In this part I have made already the necessary connections in order to establish the basis for this testing. So naturally the input power cable of the Variac itself has been connected to the AC power cord. Then the multimeter has been set in the correct measuring range. The test probe leads have also been connected into this plastic coupling with metal connectors in it, and also the wires from this induction motor through this male and female socket have also been inserted into the corresponding slots on this coupling. And I've made the grounding connection of this wire through this alligator clip onto the bolt or screw that is screwed into this metallic enclosure in order to make the grounding connection so everything is safe for testing. I'll just zoom in a little bit on this part so that you'll see how everything is plugged in, and then we'll start turning that improvised knob, same or previous as before, with 50 volt AC increments, and we'll see when the shaft or the axis of the rotor will start to spin. Now this is up close how this connector looks like and how the wires have been inserted. Here actually, because I'm in luck, the color coding pretty much matches the same one on this side of the cable. So blue goes to blue, brown to brown, and this green one to this green and yellow one, which indicates grounding. Now just a quick glimpse on this side. This is this grounding wire that I thought I'm just going to push it underneath this screw, but it comes off very easily, so I decided to use this alligator clip in order to make that grounding connection to make everything safe. Now I'll start turning this improvised knob clockwise, first with the initial 50 volt AC, to see whether this shaft here will start to spin, or the rotor, and we'll see how that goes. So we didn't get anything with the initial 50 volts, but we didn't get the shaft to start to turn at somewhere between 54 or 55 volts. But because I have tested this previously, we can achieve rotation even as low as, I think, 35 volts if we push the axis a little bit. So I'm going to show you that as well. It's actually 37 volts AC when the rotor starts to spin. If we give it a little push, it's not 35. So this is very, very slow rotations per minute, or RPM, but nevertheless this is the actual lowest, you could say, axis assisted voltage at which this induction motor starts to spin. But of course you'd have to take into consideration there is no load on this. If I was to have a pulley system attached to this, of course it wouldn't spin at this low AC voltage, so bear that in mind. So I have adjusted the voltage back to the previous part of the experiment, to 55 volts. You can also hear the motor running, so it's a little bit loud, but nothing too fancy, nothing irritating. So 55 volts is definitely when the motor, when it is not under load, this is the speed when it starts to turn. So now we'll go to another 50 volts up, and then again 50 volts and so forth until we reach 230 volts, which is the rated voltage for this induction motor. So this would be the AC voltage, the one that is in the US wall socket, approximately 110 volts, 150 volts. So the motor is a little bit louder, but not like anything in regards to those fans that I was testing in the previous video. What I've also been able to detect that as soon as I went from 55 to 115 volts, the audibility of the motor has increased, but when I went from 115 or 110 to 165 volts, the noise hasn't really increased that much. So probably when I'll go to 230 volts, the audibility will pretty much remain the same. Well, let's find out. Yeah, it's still the same audibility, perhaps more vibrations on the metal casing. Yeah, I'm definitely on the floor. I'm sensing a bit more vibrations, but the audibility of the drive, the motor, is pretty much the same. Maybe I can zoom out a little bit. I think that you can probably also hear it. Well, I'm done testing this motor, so now I'm going to connect the other one, this one right here, with the more rusty screw into the same position and setting or setup, and then we'll test the other one. I have connected the other motor in the same manner as before. I just uncoupled it from this male connector and this female socket, and then just connected the ground wire to this same alligator clip and onto this bolt here. You can see a little bit that this is the different motor because it has this rust here. I'll of course zoom in at this part so you'll be to see that this is the different motor. I have the other one actually here, so you can see that this is the different one because it doesn't have this corrosion here or corrosion on this bolt or head of the screw. Neither of the other two have this rust, so it's definitely the other motor. So again, confirmation, this is the other motor because you can see this small trace of rust over here. So I'm not still going to be testing the same motor as I was previously, so this is the other one, definitely. I have again set the AC voltage to 37-38 volts to see whether this motor, as well as the previous one, will start to spin when I give it a little push on the axis. So this one doesn't spin at 37 or 38 volts when I add a little bit of rotational kinetic energy. So let's see if it spins at 50 volts. Alright, let's give it a little push. Alright, now this does work. You can hear it speeding up. So this one spins nicely at 50 volts if we give it a little bit of a push. Now let's go to the usual 100 volts. You can hear the audibility rising, or the noise. Maybe I can zoom out a little bit. But the sound is a little bit different in comparison to the first one. Maybe the uneven flat surface underneath the motor is having that effect that the vibrations are sounding or translating differently. But at least to me it sounds a little bit different, but still, you know, it works. Let's go to 50 volts up again. So spinning nicely. So 200 volts. I pressed it down a little bit on the surface. Yeah, a little bit more vibration, just as with the previous one. So this is the rated maximum voltage. So the motor, even the other one, works perfectly. So this is the first one. Another thing worthwhile mentioning here is that because this motor has so low revolutions per minute, as you have probably seen on the sticker, somewhere between 1500 and 1800 RPM, you can, if I was to grab the axis of the motor and try to stop it, it can stop. But of course I won't advise you to do this, but just, you know, for visual reference, that the revolutions are not that high, but nevertheless still the motor works as it should. So for this part of the video presentation, or the entire video clip as such, I have finished. I have nothing else to say, to add, to show you. So in conclusion, I hope you liked this video presentation on testing these two induction or asynchronous type motors. And as it goes, like, comment, if you wish, subscribe, share, and we'll see you, if necessary, in the comment section. So this is David saying goodbye.